Hello, everybody. I'm Oren Pencil. I'm the field CISO of EMEA in the Tanzu team, and with me.
Hi, I'm Naranavan Chen, and I'm a Senior Product Line Manager responsible for Tanzu Service Mesh.
In the next 45 minutes, we will go over how to secure a modern application in combination between Tanzu Service Mesh and Carbon Black Container Security. In our agenda today is basically going over securing modern applications, why it's important, how do you achieve that, what are the different layers and aspects that you need to consider when you're thinking about securing your modern applications. What will you get out of it? First of all, an overview of VMware modern application security landscape. We're going to go over different services, different products to tackle that security challenge on the modern application side. Understand the key technical points of Service Mesh and Carbon Black. Most of the session will be a demo, so you will be able to see up and close what we are doing with those two different products in that modern application security landscape. And of course, you will understand the better together story and how do we address those kinds of security aspects in our portfolio. Why container security? Well, if it's not obvious, first of all, there's a lot of containers growth going on in the world. By 2025, more than 85% of global organizations will have some kind of containerized application. Security is a top concern for those organizations. It's a new landscape, it's a new workload. Basically, containerization, modern application, cloud native workloads are new in any layer of the infrastructure. It's a new infrastructure. It's a new networking. It's new for everything. So that challenge and that concern will definitely have an expected growth on the market. From 2 billion to 6.5 or more than 6.5 billion by 2025. Now, the most important part is what our customer thinks about it. And 97% of the responders says security in Kubernetes is a challenge. I think it's mostly because it's an unknown charter, it's an unknown territory for them, so it's definitely a concern. Now, alongside of that, because it's unknown and because most of our customers didn't do anything they can do on that landscape, we see more than quadruple the amount of cyber attacks attacking that specific landscape and those workloads. So first of all, let's go over like a Mitri landscape of an attack, how the attack looks like, and what can you do about it, or what different areas of expertise is important to implement in each and every one of them. So of course, Mitri has 5 different steps: initial access, privilege escalation, lateral movement, command and control, and data exfiltration. We have in each and every one of those steps, we have different aspects of ways to tackle that challenge or tackle that exposure. First thing, before even getting that in that initial access, you have to know how much vulnerabilities you have in your workloads. In cloud native landscape, it's different from others. A container image has all the different aspects that the code need to run. So understanding what's the vulnerabilities in each and every one of the layers, and if you have vulnerabilities in the code, of course, detecting malware behavior or malware code in that image, and understand if everything is configured correctly and doesn't have like excessive permissions is crucial in that specific initial access. Alongside of that, when it's already running, it's definitely easier in a cloud native architecture to understand if there's any anomalous activity. Cloud native is a declarative architecture, so that means that we know what should happen once the workload is running. And if something is deviating from that, that's definitely something that we can identify as malicious activity. In the privilege escalation side, again, it's making sure that the configuration of Kubernetes is according to the best practice one. Kubernetes as a layer, as an API layer, has the potential, or is the infrastructure for any workload that runs on it. Kubernetes manages everything from networking, identity, storage, compute, and everything else. So if Kubernetes isn't configured correctly and doesn't have like the right security best practices implemented on it, it has a potential like it's a new attack surface, which easy to attack. And again, in the run side, on the privilege escalation, anomalous behavior and container access controls. Anything which shouldn't be there, shouldn't be there. If it happens, definitely something that you need to consider as malicious. Lateral movements, it's again secrets and permissions and ARBA control. So again, making sure that it's hardened and it's configured correctly, and anything that is running against anything that shouldn't be there, that's an anomaly that should be addressed. Once you get into that lateral movement, everything from there onwards will be runtime security, understanding if something is wrong, if the workload is trying to connect to a new destination through egress connectivity that wasn't there. And of course, when we will get into the service mesh, encryption between all the microservices is crucial. And even when you're getting outside of your cluster and in a cross-cluster world, the global namespace structure of service mesh will allow you to make sure that everything is encrypted and everything is managed under the same network fabric on layer 7. And so, yeah, we're going to get into a lot of different aspects of that MIT-tree map in our demo. So let's go over a couple of different services and products that we have before diving into the demo. So the first thing is basically understanding what's going on, giving you eyes on what's in that environment, how it's running, and how it's connected, observability matrix to better understand what's the user experience and how it's connected between the dots. That will also have implications of security, of course. So integration of the app layer in the security traffic management, cloud native automation with elasticity, rich observability, and operational simplicity. Everything will be shown as part of the Tanzu Service Mesh Enterprise Edition. What you see here on the map, that's the AVI load balancer or the NSX advanced load balancer that allows you to get a lot of insights on what's going on in your environment from outside to from the outside world to the application. Inside that Kubernetes cluster, the networking stack is crucial to have that controls and to manage that networking as a managed networking stack. Implementing Antrea, which is our open source CNI, will allow you to get that visibility and controls on the networking stack on Kubernetes. So it's even before you're getting to implementation of application networking, which is service mesh basically on the layer 7 aspects. Antrea will have a lot of control on layer 2, 3, and 4 that allows you to manage the traffic, get visibility on the traffic, and actually connect also to our NSX control plane to have full visibility across different types of workloads, VMs, Kubernetes clusters, and so on and so forth. Service mesh is a crucial step that you have to use to get that visibility on what happens on the application connectivity side. End-to-end connectivity and security data plane that is building is an open source project on Istio. We will get to a lot of deep dive in the demo that Niran will do. And everything inside that service mesh that happens will have a visibility map and dashboard that allows you to understand exactly what's going on right now in your cluster, live traffic monitoring, and understanding if it's right or wrong, like if it's malicious or not. And in that aspect, we have all the API security of the Tanzu Service Mesh that allows you to discover all API endpoints, map the connectivity between them, get the pattern of normal behavior, and then detect if there's any anomaly in that behavior of API connectivity. And of course, also implement application policies between that different microservices to make sure that everything that goes on right now in your cluster is right. Next is our Carbon Black Container Security product or service. The Carbon Black Container Security sits underneath that service mesh. As I said with Antrea, Antrea is managing the CNI stack, the networking stack. Carbon Black Container Security is one of the services that allows you to secure the runtime environment of the containers, regardless if they are part of service mesh or not. It sits on the Linux OS. It's using eBPF kernel modules to understand what exactly networking calls and system calls is being made by those containers. And it allows you also to understand if that Kubernetes workload is running against a best practice policy that you've configured beforehand. So if there's any excessive permissions, if it's not running in the right hardening best practice way, what's the image that is being used? Is there any vulnerabilities for that image? Now, everything that I've just mentioned is on the runtime side. That's after the effect, after those containers are all actually running on your Kubernetes cluster. But Carbon Black also allows you to interject those security measures way sooner. So shifting left your security into your development cycle and taking that image scanning and Kubernetes object validation, manifest validation, and understand like if it's hardened or not, way before you're actually creating a workload that is running on your Kubernetes cluster. Runtime security in Carbon Black allows you to also understand what is the network traffic underneath that service mesh and is it right or wrong. So same AI model of behavior for those networking stacks, and according to that behavior decide if it's malicious or not. If it wasn't happening in the learning period for that behavior, it will allow you to raise an alert. And in Carbon Black specifically, it's more a workload security kind of a service, which allows you to have a more comprehensive solution and more comprehensive view, not just of the Kubernetes workloads or the containers, but also other VMs, cloud services, and cloud workloads that you will have interacting with those Kubernetes workloads. So between VMware Tanzu, VMware Carbon Black, and VMware Tanzu Service Mesh, you will have a full stack, security stack solution going from the development cycle with the development framework and a lot of other capabilities to running a workload in production in a multi-cluster, multi-cloud environment. If we want to deep dive a bit more, let's take that overall software supply chain from the build itself, enforce security on the build, making sure their developers are developing code as they should, taking development frameworks as best practice to make sure the code itself is not vulnerable, enforce compliance on that code and build of the container image, because once you're building that image, the code has all the application dependencies and application runtimes it needs, including an OS inside that container image. So enforce compliance and verify the registry that is basically the gateway between the development cycle and the production. Container registry is crucial point in that software supply chain to make sure everything is secured even before you're trying to deploy something. On the deploy side, understand identity vulnerabilities, secure applications, and at the ingress side, secure the connectivity from outside to within your Kubernetes cluster, and getting into the run state where you're protecting containers, encrypting everything end to end, securing monitor your API endpoints, which is basically just any other like any other workload. You need to make sure your API is secured and manage everything across different Kubernetes clusters, across different clouds and different infrastructure providers. And in this case, you have to have also the option to automate remediation, either through your service mesh or through your Carbon Black security that runs on the cluster itself. Let's go to the demo. Acme Fitness application is the major application that we will use in our demo. It's a polyglot application that has different microservices, one from front end and the other is either application or backend services. And what we will start with is taking a look at those different workloads with Carbon Black Container Security Dashboard. So taking a look on the lower level, what are the workloads that are running, what's the vulnerabilities, what's the risk assessment, and then we can go and transition with the same application to Tanzu Service Mesh and take a look on how the connectivity between the different clusters happened and what are the capabilities that we are bringing in the service mesh layer. So let's start with Carbon Black Container Security. What you see here basically is the dashboard of Carbon Black Container Security, and you can see that in the inventory clusters, I will see two different clusters. one for the front end, one for the back end. If I will go to workloads, I will see all the workloads that are running right now in my cluster, and I can go to networking to see actual connectivity between all of those different workloads. Let's take the front end as an example, and I can see that there's a Istio implementation. That's the service mesh. That's the same cluster that you will see afterwards in Niran's demo. But what I want to have a closer look on is the workload itself and the vulnerabilities that workload has. So if I will go to the Acme front-end namespace or the Acme namespace in the front-end cluster, I should see my front-end workload, which is the shopping. And if I'm clicking on that shopping, I see that basically all the connectivity happens through Istio, which is perfectly fine. It's managed by Service Mesh, and we will get to that. But what I care about is to see what's running in that workload. I can click on View More on the right side, on the workload side, and now I'm getting into a workload page. That will show me what is the pod it is running, where it's running. More importantly, it will show me what's the image that is running. Now, again, that's not part of my development cycle. It's not injected in my development cycle. It should have been, or it should, but right now, what I'm checking is the runtime state. So in the runtime, that's the image. It has a lot of vulnerabilities. I can click on that image and I will see what are the packages that basically forms that image and what are the vulnerabilities that is part of that image. So you can see there's at least 4 critical vulnerabilities, then there's a lot of different high vulnerabilities. Now, Carbon Black Container Security manage not just this cluster or this workload. So when I click on Kubernetes workloads, if there's any other workload that is using that specific image, it will be shown here. In this case, that's the only workload that runs that image. But if I had a lot of different clusters running a lot of different versions of Acme, I would have seen exactly what are the vulnerable workloads that I should take a look at and should basically repair. Now, that aspect of the workload is basically the container image, pods, and everything that is running. What the next layer or the next level of hardening will be to check out what's the Kubernetes policy or what's the violations on the Kubernetes side, and if that workload is running against the policy that I've configured. So that workload is not running according to my policy. It's running with root permissions, which I don't really allow. It doesn't have any memory limits or CPU limits, so that potentially can allow an attacker to have a noisy neighbor situation where it's overloading a specific workload that will affect the entire node or the entire cluster. And it's running with privilege escalation, which I'm not, again, totally allowing. It's also running with SEComp profile. Now, you see all those violations. Those violations already happened because the workload is already running. If I want to change anything with those violations, I will need to change the manifest or change the declarative state of the workload and then redeploy it on my cluster. Now, I can also see in the runtime side what's the behavior that I'm expecting from that. That's an eBPF model that listens to the networking call of the workload. And in this case, I can see all the communication comes in and out through the Istio, which is exactly what I'm expecting because everything is being managed by Tanzu Service Mesh on the application layer. And we will get to that in Niran's demo. One last thing is container images. So container images, as I said, we've just took a look on one specific workload, but you will have the option to see and view all of your container images in a dashboard, all the deployed images. So all of those images are running right now. Now you can see here that several of them are running more than once. So you can see 2 workloads that are running that specific image, Matrix Proxy, and it has vulnerabilities. So it's not just a vulnerability in one specific workload, it's more than that. Image repositories will allow you to integrate to your local registry or to inject that security measure inside your development cycle, which means that once you're building that container image, you will automatically scan that and basically have all the details around vulnerabilities in this dashboard. Last thing is, if something is not right according to the behavior of that networking stack, you will see that in the alerts page. The alerts page is here to basically show you if there's any abnormal activity from any workload that wasn't learned inside that behavior analysis model. And you can already see there's a lot of different errors and alerts that I'm getting here. That's because my learning phase was too short. And right now you see a lot of expected behaviors like Istio-D behavior that looks like an anomaly, but it's not. So I can just add that to baseline in the policy, and that's it. It won't alert again. In the hardening side, Kubernetes violations, I will see all the violations that I have. And again, that's against a policy that I've pre-configured, and that's on already the running state of the workloads. So it's not something that I'm checking before it's running. All of those violations happens after the running state because I didn't stop them as part of my development cycle. You would want to inject as many security measures in the runtime, in the development side, but you should have all of those inspections also on the running side. Now, that's the lower level side of things, getting the understanding of vulnerabilities and misconfiguration of Kubernetes even before you're getting into production. Once you're getting there, you can see everything in that running state in production as well. But now let's elevate ourselves into the application layer and see all the capabilities that we have connecting the dots. By the way, you can see that in this case, what I have in the Acme namespace is just one workload, which is shopping. All the other workloads are in a different cluster, the Acme backend in a different namespace. So the connectivity between those two clusters is not visible through Carbon Black Container Security because it's in the application layer. And I think that's the perfect point to transition to Niran part of the demo and basically take us through the same Acme Fitness application, but getting into our global namespace structure.
Let's look at a demo. We have the front-end microservice, which is called the shopping service, which I deployed in AKS, Azure Kubernetes Service, which is Azure's managed Kubernetes service. I deployed the shopping service in both US East and US West sites for highly available purposes. I also deployed the backend services, which are the catalog, the cart, its database, and there's a bunch of other services. I deployed them in AWS. This is actually TKG, which is VMware's managed Kubernetes service deployed on EC2. It really doesn't matter because tons of service mesh, as I said before, will work on any supported Kubernetes cluster. Now what we're going to do is create connectivity between all these services by establishing a service discovery domain called acme.lab. I'm going to show exactly how that works. And the connectivity is going to be established. It's going to be all MTLS encrypted end-to-end across clouds. This application will also be published through an AVI network GSLB, so NSX Advanced Load Balancer acting as a global load balancer, which will point to the to Azure site by defining shopping as the published service. So in essence, we're going to create a multi-cloud, multi-site application published through a global load balancer. Once we have the application connected and working, we're going to apply an access policy, and we're going to see how the application also corresponds to PII data leakage protection, to API security, and east-west threat detection. Let's start going into the demo. So I'm gonna jump into my terminal here. And as you can see, I have different clusters, but I also have the two Azure sites and the 4 AWS sites. I'm gonna jump on the AKS site, which is basically the site here on AKS East. I'm gonna grab the pods, and you can see that I'm gonna have the shopping service here, which is the shopping service here. Let's just, for the sake of discussion, gonna go to the other Azure site. We'll see the shopping service here. And if we jump into the AWS sites, we'll see that all services are deployed here as well. So these services are deployed in the AWS site. Now, going back to the AKS cluster, if we inspect the deployment for the shopping service, we can see that it's already set with environment variables that define the service discovery domain that the global namespace will apply. Now, as I said, Tanzu Service Mesh is a federated Istio service, so we can connect to the cluster directly, which is this IP, which I'm gonna darken for security purposes. But I'm gonna connect to that site, and we see the application. It tells us that I'm connected directly to the Azure US East site. But then if I look at the catalog is empty. And this is because the connectivity between the services is not established yet. We need to define the service discovery domain by setting up the global namespace, and that will set up the DNS records that will allow the services to communicate over MTLS. Let's jump for 1 second also into Tanzu Service Mesh. We see that we already have the 4 clusters in Tanzu Service Mesh. And if we look at the different clusters, we can see inside the services are deployed. Now there's a lot to see in the dashboards for Tanzu Service Mesh around performance and information that is important for understanding your application and maintaining it and operating it. But that again is for a subsequent video. We will focus on the global namespace and its policies today. And we can see the global namespace is empty, is not yet created. If I go here, we have the AVI Network Advanced Load Balancer. And if I go to GSLB, well, it's already configured into TSM, into Tanzu Service Mesh. The global load balancing is yet to be set up, and that will happen over the demo. Lastly, before we establish the connectivity, I will run a watch on getting something called service entries, which are the DNS records, and we'll see the DNS records being created when we create the global namespace. I'm going to open another tab and we can start the demo. What I have here is a YAML file that defines the global namespace. Once I logged in, I'm going to run the command Tanzu Service Mesh to apply the global namespace definition to the SaaS service. So we apply the global namespace and it went and created the global namespace. As you can see, it already sees all the services in the 4 clusters that is part of the global namespace. We can see also in the watch that all the DNS records were created on the cluster where shopping service is. So each cluster is going to get the relevant DNS records. If we look at the DNS records here, we'll see that there are 2 endpoints that tells shopping where catalog is, for example, which are the ELB addresses for US East and US West clusters, if we look at the diagram, that we have here. So this shopping service now have a DNS record to point to the US East and US West clusters. This basically means that no developer need to know these addresses and only need to point to the logical configuration. Now lastly, in the AVI networks, we see that the global load balancer was configured, and it points to the 2 Azure sites. If we go into the actual domain, we see that we get connected to Azure US West, and the catalog is now being populated. And we can see that the actual products are coming from Amazon US East and US West. So we get a full mesh across the different clouds and services. Let's now look back at the Tanzu Service Mesh. I have a load generator generating traffic on the application. So if we're going to click into the global namespace, we'll see that a map of the connectivity between the services is being formed. In this case, we currently see connectivity coming from US West into the shopping service. And from the shopping service in US West, it goes to AWS East and West connectivity to the catalog. And as time passes, we'll see more connections being formed from both sides. This provides us not only with information about how the application is operating and some information about performance, what we called the 3 metrics. It also shows us the dependency map between the different services. We can see which services are supposed to communicate with one another. This will allow us to build better policies around microsegmentation and zero trust. At this point, we have a working global namespace. All services are communicating with one another, and everything is encrypted. Let's now start looking at the different policies. The first set of policies we want to set is access policies. Going into the inventory, we'll see that there's a section for service groups on the global namespace, which is empty. Let's create those. I have a YAML definition for that. So if I go to service groups, we can see that it defines different services like the catalog and the shopping service and order service and every service that needs to be connected. I'm going to apply that to my global namespace. And this goes and creates all the services global in the system. And the second thing is to create access control policies. For this purpose, I have a YAML file that defines access policies, and we can see that it says which service and which service are allowed to talk. Once we set up that rule, everything that's not allowed is be automatically blocked. So we're going to apply this the same way. At this point, we'll see that all the access policies are created. And there's a nice representation of that in the global namespace. If we go and click on security, we can see the green check mark that basically says that that connectivity is allowed. Anything else that's not set here is blocked. Let's see how this works. If I look at my application here, we see that we have the catalog. I'm going to refresh the page again. We see that we have the catalog here. Let's now block one of the connection. Let's block the connectivity between shopping service and the catalog. I have a YAML definition that sets the to block with a deny. Well, as soon as I apply that in my global namespace, we'll see the connectivity from shopping to catalog is blocked. Now you can see that it's blocked anywhere shopping exists and anywhere catalog exists. I didn't really need to specify any IPs or sites, just the logic, which service is supposed to talk with which service. If I go to my application now and I click refresh, we'll see the catalog is not coming up. Let's unblock ourselves by applying the allow again to change the policy back to allow. Now, this is basic connectivity security that's usually expected. We can apply that automatically across different clouds, across different sites, across different vendors, as I mentioned. But there are additional things we can do that are more advanced than that. Let's start looking at those. We see that our application is back to work. First, we want to look at where does data that we care about moves in the application. If I click on PIIs, I can see that there's 0 PIIs here. What I want to do is run a transaction and buy something in my site. Let's buy the water bottle. I'm going to add it to cart. I'm going to go to cart and I can see the water bottle here, well, a bunch of things. Click proceed to checkout. I'm going to add some information here. And I'm going to go to delivery. And this is the important part. I'm going to enter a pattern that corresponds to credit cards. And I'm going to place an order on all this merchandise. So let's jump back into Tanzu Service Mesh. Now we see the application, and if we click on PII, we see that a blue line was formed that shows us where the credit card was passed. So we see that the credit card came in from the shopping service and was passed down to the order service and down to the payment service. I click twice so I can see that coming from both ways. This allows us to model the application better and understand where the data is. Understanding where the data is also allows us to set up policies then to enforce data leakage protection. Let's look at it further. If I click into this service here, we can see the PII and we can see exactly which API calls carried PII data in them, which is the credit card number here. I can look at the API calls here. I can double click into that and I can see different analysis on the API call itself. For example, I can see the events, the source service that talks with it, the response codes, the top users, the top errors, the geos. We can also see performance information on the PII data. Performance information on API calls is super helpful when we're troubleshooting an application issue. We can understand how the API behaves, and then we can correlate that with information about the actual compute that it's running on and the network, and that will allow us to pinpoint problems better. Now, when it comes to API management, we can also go and look at the schema of the API call and drill down into the parameter level of the APIs, and we can take the API in JSON format and document it aside. Later on, I will show how we can create an API security policy that can control which API calls can happen and which can't happen on the service. Let's look at additional capabilities. So if we click on the application here and we're looking at attacks, we see that there's clear from attacks. Now we can go in and apply a threat detection policy, and I can go in and create a new policy, and this will allow us to set up OWASP 10 attacks threat detection on our services. So in this case, I'm applying this on the global namespace. I'm marking all the different attacks we're looking for. You can potentially add any custom attack, for example, log4j, by adding here the signature of that specific attack. We can control the paranoia level. If you're familiar with WAF, this is the level that enables the rules attacks. And we apply this on all the services. Now we have a rule that allows us to search for specific attacks on our global namespace. Now we can go here back to the application, the global namespace, then we can apply an attack. So let me grab here a URL that allows me to attack my application from outside. And now we ran an attack on our service. Let's look now at the global namespace. Now we see the system has detected the attack. If we hover over it, we can see that that was a SQL injection attack and a protocol violation enforcement. Let's click into it, and we can see here the API calls, and we can see exactly which API call had an attack. If we go to our security dashboard and we click on security events, we can see all the different events that happened. Anomalies around new API calls that were never detected before, and the attacks that happened as well. Now let's see how we can create a policy around API security. We can add a new policy and choose which service we're going to apply the policy on. Let's choose another service. Now we can control different aspects of the API level. We can control which PII data is allowed. For example, we can say this service is only allowed to carry credit card numbers, but it's not allowed to pass ABA routing numbers on it, nor any SSN information. Now this is important because now, and we can put the status code here. This is important because now if anyone hijacks this service and tries to pull new type of information that is not allowed, we can block it. So basically we can prevent leakage of data. The way security attacks happen is someone compromises a service and then they try to elevate themselves and pull information from other services. So this will block that type of attack. We can also control which API calls are allowed. Either we learn the API calls and create a policy and import it as open API, or we can add the APIs manually by saying /product is what allowed. And then we can save this API call. So what we've saw is that we can control different aspects of the application. We created this global namespace to create a multi-cloud application that automated the service discovery and the MTLS and certificate management. We then created security policies around access, which microsegmented our application completely, around PII data that we can control which type of data is flowing through our service mesh, WAF type capabilities around east-west threat detection, and API security that we can allow us to witness, analyze, and control the different API calls that are happening in our application.
Thank you, Niran, for an amazing demo. Your top 3 takeaways from this session. I hope you've enjoyed the demo. The first thing is seamless connectivity. Connectivity is crucial in microservices. Instead of having everything running in the same OS in the same server, with microservices, each web server becomes 20, 30, 40 containers, workloads that runs all over the place. And you have to connect the dots, you have to secure the connectivity, and you have to make sure it's running exactly as it should. Zero trust security, nothing should happen if it wasn't designed to do that. It's a declarative architecture, you know exactly how the application should behave, and you have the option and capabilities with our solution stack to make sure that's exactly what happens. And simplify DevSecOps. DevSecOps means shared responsibility between the developers, the security, and the operations to bring code as fast and as secured a way they can from code to production. So address those developer needs, and making sure that you inject security as soon as you can will allow you to help that DevSecOps lifecycle and not getting in the runtime or the production environment, but getting in as soon as you can inside that inner loop of the development cycle. Call for actions. You can read more about Tanzu Service Mesh, Carbon Black Container Security, and there's a lot of hands-on labs and test drives to actually test that technology. Thank you very much for being with us. I know Niran and I are excited about the future. I hope you are as well. Have a great day, and thank you, EMpower.